This video is a part of a series on how to develop an embedded coder target for hardware platform based on ARM Cortex-A processor. We are using the ARM Cortex-A reference target and the target SDK to build an embedded coder target for BeagleBone Black. So far we've covered an introduction, we have registered the target, and we have added the application deployment feature to it. In the last tutorial, we created an executable file from a Simulink model. In this tutorial, we will add the scheduling feature that will allow us to run the generated code on hardware target. So let's get started. We'll follow these steps to add the scheduling feature. First we add the feature, then we map the feature to the hardware, save the target and set relevant MATLAB preferences, and finally test the feature that we just added. An ARM Cortex-A processor typically uses an operating system for scheduling application code. The generated code includes scheduling code that executes the application code based on sample times in a specific model. So first, we add an operating system to the target. The SDK supports two operating systems, Linux and VxWorks. Since we are using BeagleBone Black as the hardware, we set the operating system to Linux in this case. So let's execute these commands and make sure we can see the effect in the target. So as you can see, a new operating system feature has been added. The deployment feature from the previous tutorial is enabled for my BeagleBone Black, but the operating system is not yet enabled for my BeagleBone Black. To enable this, let's map the feature to the hardware. I'm executing these commands. By mapping this feature, we've enabled it now to the my BeagleBone Black. Let's save the target. And next, we are going to set a few MATLAB preferences to specify hardware information. If you remember in the last tutorial, we added a load command to the target object. The load command will work if the hardware runs Linux operating system and supports SSH protocol. The load command also needs to know the IP address, a set of username and password, and the default build folder. And this is exactly what we are setting in the preference commands right here. Note that the name of the hardware, my BeagleBone Black, is encoded in the preference name. So let's execute these setpref commands to set relevant MATLAB preferences. And finally, let's test the feature. The testing will take a couple minutes. We are going to run through it faster in the recording. And here we are basically testing different configurations of Simulink models with multi-rate, single tasking or multitasking settings. Now that the test has passed, we can see this feature in action. Let's open up a model, Simulink model, and let's make sure we have different rates. So it's a multi-rate configuration. In this case, this constant block is set to a sample time of 1, whereas this other constant block is set to a sample time of 2. So we got this multi-rate model. Now let's look at the configuration. Under hardware implementation, we've picked the hardware board as my BeagleBone Black and selected the right target file and the toolchain information in the code generation panel. So with that, we are ready to build this model, and this will now run on the target hardware, which is BeagleBone Black. As you can see, it started running the model on the target, and the build was successful, which is great. Looks like the feature is working. Now that we've seen the feature in action, let's look at the generated code right here in the ert_rtw folder and open up ert main.c to look at some of the code that's generated. As you can see, there are different rates in this model, and corresponding to the different rates, you will see different functions in the ERT_main file. You can scan through the code to really understand the details. Under main, you can see the different functions that have been called to really understand the generated code. And that concludes the tutorial on scheduling feature. Thank you.